All right, section 10.6. Our radical equations and problem solving. So we're going to start off with how to solve equations that contain radicals. If both sides of an equation are raised to the same power, all solutions of the original equation are among the solutions of the new equation. So if both sides are raised to the same power, anything here. So we have the square root of x plus 1 equals 5. So we're going to put this in terms of, we're going to do inverse operations. So the opposite of taking the square root of something is to square it. So we're going to square both sides. And remember, we kind of talked about how when you square or square root, it's like the key that sets your radicand free. So it's going to become x plus 1 equals 25. And then I'm just going to subtract 1. And so I get x equals 24. I can check and make sure that it works. So I'm going to plug in 24. I said 21, I'm sorry. 24 plus 1 is 25, and the square root of 25 equals 5, and that's what I got. So, ta-da! It's true. I'm so smart. You're so smart too. Okay, so the solution is x equals 24. So, here, when you're solving a radical equation, step 1 is we want to make sure we isolate one radical on one side of the equation. We're going to raise each side of the equation to a power equal to the index of the radical and simplify. Remember, your index is the little number on the outside of your house. Is it a 2, a 3, a 4, a 5? And the power is the exponent of a number. 3, if the equation still contains a radical, we're going to repeat steps 1 and 2 to get rid of that radical. If not, we're going to solve the equation. 4, we're going to check our proposed solutions in the original equation to make sure that they are valid solutions. So we're going to start here. So step 1 is we have to get our radical by itself. So that means I have to move a negative 1. So the opposite of being a negative 1 is a positive 1. So we're going to add, we know that we are going to add 1 to both sides. Add 1, and I get the square root of x minus 1 equals 1. Now we're going to do the opposite of taking the square root, which is squaring both sides. We set our radicand free. We are almost there. So the opposite of subtracting 1, again, is still to add 1. And I get x equals 2. I want to make sure this is a valid statement. So I'm going to plug in 2. I'm going to check. 2 minus 1 is 1. The square root of 1 is 1. And 1 minus 1 equals 0. Yay! Our solution is x equals 2. So here we're going to need to get our radical by itself. So I'm going to need to subtract this 2x because it's a positive 2x. I'm going to make it a negative 2x. What I do to one side, I do to the other. So I'm left with the square root of x plus 1 equals 8 minus 2x. I'm going to square because the opposite of taking the square root of something is to square it. When I square the radicand, I get x plus 1. And when I square 8 minus 2x, I'm going to remember my properties. And so it becomes 8 times 8 is 64. I have to do 2x times 2 times 8, and that gives me 32 plus 4x squared. So if you do not want to remember the property, or you get frustrated with remembering the property, you can always just FOIL. So we can always do 8 minus 2x times 8 minus 2x. And I'm going to get 8 times 8 is 64. 8 times negative 2x is negative 16x. Negative 2x times 8 is negative 16x. And negative 2x times negative 2x is plus 4x squared. Notice all I did was combine my middle two terms. So after I do that, in this situation, we have to get one side equal to 0, and the reason why is because I'm now working with a quadratic. Quadratic means that my highest exponent is squared. So in order to solve a quadratic, you have to get one side equal to 0. So I'm going to need to move my x plus 1 to the right side. So I'm going to subtract x from both sides, subtract x, and I'm needing to subtract 1 from both sides. And that's going to leave me with 0 on the left side. So I have 64 minus 1 gave me 63, negative 32 minus 1x gave me negative 33x. I'm going to use any factoring technique I like to solve for my x, well, my factors. So I'm going to factor, and I get 3 minus x times 21 minus 4x. Remember, at this point, we're going back to chapter 6, where we learned all of our factoring skills. So you can use the tab and box method. You can do not completing square. You can do grouping, factor by grouping, not grouping. I'm having some. It is almost 10:30 at night. And so whichever method you want to factor by, if you still need some refresher on factoring, please be sure to let me know, and I will send you some helpful links or help you with a specific problem in your homework. But here are my factors. Remember to find solutions to your factors. You set them equal to 0. So I would set so I would set 3 minus x equal to 0. And my goal is to get x by itself, so I might as well just go ahead and add the x. So now I know that 3 equals x, or x equals 3. And then I'm going to do 21 minus 4x equals 0. I'm going to subtract 21. Subtract 21. I get negative 4x equals negative 21. Divide by negative 4. Divide by negative 4. And I get x equals positive 21 over 4. So my two possible solutions are x equals 3 or 21 over 4. So final step. So first I'm going to plug in the 3, see if I get a true statement. And I did. And this is because the square root of 4 is 2. And that leaves me with 8. I'm going to plug in 21 over 4 and see what happens. So I end up with 21 over 4. And I get 21 over 2 plus square root of 25 over 4. And that ends up with 5 over 2. And 21 plus 5 is 26 divided by 2, which does not equal 8. So it's a false statement. So therefore, my only solution is x equals 3. And we call 21 over 4 an extraneous solution. It's not a real solution. It's an extra. All right, so here's an example when you have two radicals on both sides. So we're going to square both sides right off the bat because I already have at least one radical by itself. We're going to follow our squaring rules. So I square both sides. I'm going to either FOIL or use, I'm either going to FOIL or use the shortcut to factor the right side, not to factor, to expand the right side. Once I do that, I'm then going to combine like terms. So notice here I have a positive 4 and I have a negative 4. So they're going to cancel out. So I'm just left with 5 equals negative 4 divided by negative 4 times the square root of y over 4. Remember our steps said that if I end up with the radical again, I have to repeat the steps again. So now I'm going to get my radical by itself. I'm going to divide both sides by negative 4. Divide by negative 4. So I divide both sides by negative 4. And now I'm going to square both sides. Once I square both sides, I end up with 25 over 16 equals y minus 4. I need to get y by itself. So I add 4 to both sides. So y equals 4 plus 25 over 16, which equals 89 over 16. So for this, I just need a common denominator, I mean a least common denominator, and my least common denominator is 16, obviously. So how does 4 over 1 become 16? I multiply the numerator and denominator by 16. 4 times 16 gives me 32. Not 32. Excuse me again. I am going crazy. It gives me 64. And 64 plus 25 equals 89. So now I have 16. I'm going to plug in the square root of 89 over 16 plus 5 equals 2 minus square root of 89 over 16 minus 4. And see, is it a true situation? Remember, you can use your calculator to do this. So using your calculator, you can also go ahead and do 89 divided by 16 plus 5 in the calculator. And remember, click math fraction, and it will give you the fraction of 169 divided by 16. And the same for the other side. So I simplify it, and I get 13 divided by 4, because the square root of 169 is 13, and the square root of 16 is 4, equals 2 minus 5 over 4, and that's because the square root of 25 is 4, and the square root of 16, no, I'm sorry, the square root of 25 is 5, the square root of 16 is 4. And then I keep cleaning it up, and lo and behold, it makes a false statement. So what that means is this equation has no solution. Womp, womp, womp. So yes, we did all that work to find out that there's no solution. They can never equal one another. All right. Ooh, a bigger one. Okay. So our goal again is to get the to get it by itself. It's easier to just move the negative 3x, square root of 3x plus 4, because when I add it, it's going to make it positive, and I'm still working with positive. So I'm going to square both sides. Do the same thing on the previous one, where I FOIL or I use my shortcuts. Either way, I end up with 2x minus 4 equals 4 minus 4 times the square root of 3x plus 4 plus 3x plus 4. I'm going to combine like terms, plus 4 and another positive 4. And I get, sorry, I skipped some stuff in typing. And I end up with positive 8. So I'm going to move everything away from the radical so that I can get 3x plus square root of 3x plus 4 by itself. So I'm going to subtract 8 and subtract 3x to the other side. Simplify it, and then I'm going to divide by negative. Well, I can't. I could divide by negative 4, but I didn't. We're just going to square it. It's easier to work with out of fractions, let's just be honest. So we're going to square both sides and basically repeat the process again. FOIL or follow the rules. And so I end up with x squared plus 24x plus 144 equals 16 times 3x plus 4. I distribute the 16. Doop, doop. And I get 48x plus 64. I ran out of room, but we're going to keep squeezing it all in there. Because I have my highest exponent as x squared, I know that I have to get one side equal to 0. So I'm going to move everything to the side of the x squared. So I subtract 48x from both sides. So minus 48x is what happened. Minus 64. So over here I have minus 48x. Trying to squeeze it in there. This pen and I just need to find a new one. Minus 64. And that leaves me with x squared minus 24x plus 80. So I gotta think of what two numbers add to give me 80, add to give me negative 24, but multiply to give me 80. So I get two beautiful magic numbers, and those beautiful magic numbers are 20 and 4. 20 times 4, negative 20 and negative 4. Negative 20 times negative 4 is positive 80. Negative 20 plus negative 4 is negative 24. So therefore my factors lead me to my possible solutions, which are 4, 4, 20. I'm them in, test them. I got a true, plug it in, test it. I got another true. So that means that my two solutions are 4 and 20. All right, continuing. Square both sides. Divide by 5. X equals 5. I'm going to substitute it in. And like, oh no, it doesn't work. Okay, so it does not check. So the key thing here to note is if your square root equals a negative number, there's no solution. It doesn't exist. It will never exist. No, there's no real solution to this. All right, use Pythagorean theorem to model problems. So Pythagorean theorem we've talked about before in other lessons. That's our a squared plus b squared equals c squared. So when you have a right triangle, it has to be a right triangle, meaning that this equals 90 degrees. We will call our legs A and B, and we call our hypotenuse side C. And the formula that you just plug everything into. So it says find the length of the hypotenuse of a right triangle when the length of two legs are 2 inches and 7 inches. So it told me my two legs, so I know my A and I know my B. If you are a visual person, please remember you can always draw your lovely triangle. There's my right triangle. You're 2, you are 7, and you are my hypotenuse. Your hypotenuse is always across from your 90-degree angle. It's always your longest side of your right triangle. So I plug it in. I get 2 squared plus 7 squared equals c squared. And 4 plus 49 is 53. I take the square root because I want c, not c squared. And so I get c equals the square root of 53 inches. Yay! Pythagorean theorem. It says find the length of the leg of a right triangle. And it wants us to give the exact length in a 2 decimal approximation. So that means I have a right triangle. And I know that one leg is 2. I don't know my other leg, and I know that my hypotenuse is 9. So this is my C, this is my A. So I'm going to plug them in. I'm going to simplify. I'm going to get my variable by itself, and then I'm going to take the square root. So I now know that B equals the square root of 77, which is approximately 8.77 inches. All right, what about in a word problem? Does it change anything? No, not at all. So we have a surveyor must determine the distance across a lake at points P and Q as shown in the figure. To do this, she finds a third point R perpendicular to line PQ. If the length of PQ is 320 feet and the length of QR is 240 feet, what is the distance across the lake? So she has drawn the distance. We've drawn a picture. We labeled our picture. So let's label what we have. We know that C is our longest side. B and A are my legs. So here's an A. And so this would be my unknown B. I'm going to plug them in. Using my handy dandy calculator, I found squares. I'm going to subtract to get B squared by itself. And I'm going to take the square root to get B by itself. And so B equals 80 times the square root of 7, or is approximately 212. And ta-da! Pythagorean theorem. That's how many approximate feet it is across that lake.